Hi, Dr. Sandoval. I'm having a bit of trouble with this dosage calculation. The problem states to give a patient 19.4 milligrams of Mockamine in 496 milliliters of D5W to be infused at 15,650 micrograms per hour and asks for the flow rate in milliliters per hour. I tried to figure out the drug concentration in the bag, but then I got stuck trying to connect that to the infusion rate and convert everything to milliliters per hour.
This problem certainly has a few moving pieces, Priya, especially with the different units for the drug amount. It's easy to get tangled in which number to use where. Let's start by clarifying what information we have and what we need to find. We're given the total amount of drug in the bag, the total volume, and a target infusion rate, and we need to calculate the flow rate in milliliters per hour. Before we dive into calculations, what's the first thing you notice about the units of the ordered infusion rate compared to the drug amount in the bag?
Well, the Mockamine in the bag is measured in milligrams, but the infusion rate is given in micrograms per hour. So the units for the drug amount aren't consistent. I'm not sure which one I should convert, whether it's better to change the milligrams to micrograms or the other way around.
That's an excellent observation, Priya. You're absolutely right that the units for the drug amount are inconsistent. The key is to make them the same so we can compare and calculate accurately. Given that the infusion rate is in micrograms per hour, what do you think would be the most straightforward approach? Converting the total drug in the bag to micrograms, or converting the ordered infusion rate to milligrams?
I think it would be more straightforward to convert the total drug in the bag to micrograms. So, for 19.4 milligrams of Mockamine, I'd divide by 1,000 to get micrograms, right? That would mean there's 0.0194 micrograms of Mockamine in the bag.
You're on the right track with converting the total drug amount, Priya, but let's re-examine that conversion factor. Remember, 1 milligram is a larger unit than 1 microgram. Think about how many micrograms are in 1 milligram. Should we be multiplying or dividing by 1,000 to go from milligrams to micrograms?
Oh, you're absolutely right. My mistake. Since a milligram is a larger unit, I should multiply by 1,000 to convert to micrograms. So 19.4 milligrams multiplied by 1,000 micrograms per milligram would be 19,400 micrograms of Mockamine. Does that sound better?
Yes, that's absolutely correct, Priya. 19.4 milligrams times 1,000 micrograms per milligram equals 19,400 micrograms. You've successfully converted the total amount of Mockamine in the bag to micrograms. Now all your drug amounts are in the same unit. What would be the next logical step to use this information to help find our flow rate in milliliters per hour?
Okay, so now that I have the total amount of Mockamine in micrograms and the total volume of the D5W, I think the next step would be to figure out the concentration of the drug in the solution. I need to know how many micrograms are in each milliliter, right?
That's exactly right, Priya. Calculating the concentration of Mockamine in micrograms per milliliter is a crucial step. It helps us understand how much drug is in each portion of the solution. How would you set up that calculation using the total micrograms you just found and the total volume in the bag?
Let me try this. To get the concentration in micrograms per milliliter, I would take the total volume of 496 milliliters and divide it by the 19,400 micrograms of Mockamine. So 496 milliliters divided by 19,400 micrograms. I get 0.0255 milliliters micrograms. Is that how I find the concentration?
You're getting very close to calculating the concentration, Priya, and it's good that you included the units in your result. However, let's think about the units we want for concentration, micrograms per milliliter. This means we want the drug amount in the numerator and the volume in the denominator. How would you adjust your setup to get micrograms per milliliter?
Okay, so I need to put the micrograms on top. It would be 19,400 micrograms divided by 496 milliliters. Let me calculate that. I get approximately 39.11 micrograms per milliliter. Is that the correct way to set it up?
Excellent, Priya. You've got it exactly right this time. 19,400 micrograms, 496 milliliters does indeed give you approximately 39.11 micrograms per milliliter. That's our concentration. Now that we know how much Mockamine is in each milliliter and we have the ordered infusion rate in micrograms per hour, what can we do to find the flow rate in milliliters per hour?
Okay, so I have 39.11 micrograms per milliliter for the concentration, and the ordered infusion rate is 15,650 micrograms per hour. To get the flow rate in milliliters per hour, I think I need to multiply these two numbers. So, 15,650 micrograms per hour multiplied by 39.11 micrograms per milliliter. That would give me 611,171.5 micrograms squared per hour times milliliter. Is that right?
I see you're using the concentration and the ordered rate, Priya, which is great. However, let's look closely at the units you ended up with. Micrograms squared per hour times milliliter. That's not the milliliters per hour we're aiming for. Remember, we want the micrograms to cancel out. Do you think multiplying is the right operation, or should we be dividing one of these values by the other to get our desired units?
Oh, right. My units are all wrong. I need the micrograms to cancel. So if I divide the ordered infusion rate, 15,650 micrograms per hour, by the concentration, 39.11 micrograms per milliliter, then the micrograms should cancel out and leave me with milliliters per hour. So, 15,650 divided by 39.11. I got 399.9 milliliters per hour. Does that look right for the flow rate?
Yes, that's the correct setup, Priya. Dividing the ordered infusion rate by the concentration will indeed give us the flow rate in milliliters per hour, and your units cancel out perfectly, which is key. Your calculation of 15,650 micrograms per hour divided by 39.11 micrograms per milliliter gives you approximately 399.9 milliliters per hour. Now thinking about precision, what was the precision of our original measurements, like the 19.4 milligrams or the 496 milliliters? And how might that impact our final answer?
Okay. The 19.4 milligrams has 3 significant figures, and the 496 milliliters also has 3. And the 15,650 micrograms per hour has 4 significant figures. I think that means my final answer, 399.9 milliliters per hour, should probably be rounded to 3 significant figures, so 400 milliliters per hour. Is that right, Dr. Sandoval?
That's exactly right, Priya. You correctly identified that our measured values, 19.4 milligrams and 496 milliliters, both have 3 significant figures. Therefore, our final answer should also be rounded to 3 significant figures. Rounding 399.9 milliliters per hour to 3 significant figures gives us 400 milliliters per hour. Congratulations, you've solved the problem.
Oh, thank goodness. It's so good to finally get to the right answer. Thank you so much, Dr. Sandoval. I really appreciate your help walking me through all those conversions and making sure I set up the division correctly. The significant figures part at the end always trips me up a bit.